Okay. The rule defined as, okay, what is the sum? It is the number that the partial sums approach. Okay. On the graphics calculator, the partial sums are defined by those words. Stands for cumulative sum. Cumulative sum. Okay? And I'm going to show you guys how to do it on the graphics right now, so you don't have to do any more cutting. Example 1. Generate the first 10 partial sums of the geometric series underline geometric series because this only works for geometric, and give the sum of the series. Okay. All right, let me give you the series. 2/5 plus 4/25 plus 8 1/25 plus 16 over 6/25 plus 32 over 3 1/25 plus ... Okay. Now, this only works if it's geometric. So the first thing you guys have to do is find R. If you can't find R, then it's not geometric. Okay? So grab your calculators. Take second term divided by first term. Because remember, that's how we always find R.
Do you want R in a fraction or decimal?
Either way, it doesn't matter. If it comes out to be a nice decimal, we can write it as a decimal. Okay. What do you guys have for R? 0.4.
Or 2/5.
Or 2/5. Either or is fine. Now, we really should check and make sure it's geometric by taking 4/25 times 0.4. And hitting math, enter, enter. And does that come out to 8 over 125?
Yes.
Yes, it does. Okay, awesome. Okay, so our table. What I need from you guys is I need a table. Oh, actually, I need the rule first. So the rule for the geometric series is G sub n equals. Maya, what is G sub 1? 2/5 times R. Max, what is R?
0.4.
To the n minus 1. Everybody good? Okay. All right, let's make our table of partial sums. And I am asking you for term number and then partial sum. So the first term in the series is 2/5. The partial sum is 2/5 plus nothing, okay? So that's just 0.4. Everybody good with that? Why would I put term number as 2/5? So sorry. First term is 2/5. Second partial sum is 2/5 plus 4/25. What is that as a decimal, gang?
0.56.
Yeah. Third partial sum is 2/5 plus 4/25. So just leave this 0.56 sitting on your calculator and add the 8 over 125. What's that one?
0.88.
Oh, be careful.
0.624.
I have 0.624. Okay. So, what can we say the sum of the series is? What is it getting very close to? What are those getting very close to?
7.7.
Well, it's never going to hit 0.7. So it's going to be 0.66666, which is what is a fraction? Close? 2/3. Okay. Now, do you have to generate the partial sums every time you do this? No. There is a formula. Okay. So, rule to find, on the homework I do have you generate two tables. So, rule to find the sum, bless you, of an infinite geometric series is sum equals g sub 1 over 1 minus r as long as, okay? So it does not always work if the r value, the absolute value of r, is greater than 1. The absolute value of r has to be less than 1. So when you guys figure out the rule like we did up here, if that number r is greater than 1, the absolute value of it, then it can't be done and you put no sum. That's all you guys have to do is put no sum. Okay? Can we check and see if this rule works for this up here? We knew we were supposed to get 2/3, right? So sum equals g sub 1 was the first term in the series. So 2/5 over 1 minus r. And r, you guys told me, was 0.4? Now, just be careful how you punch this. I would hit 2/5 and hit enter. So hit 2/5 and then divided by, and the 1 minus 4, guys, 0.4 has to be in parentheses. Oh. All right, did it come out to be 0.6 repeating? Should. Be careful how you punch it. I did 2/5. Okay.